Hello, and welcome to our crash course. We are the Astrolyticas and Insightellites, which includes myself, Katie Booth, Caitlin Hanafee, Julia Realander, Nicole Jackson, and Rachel Crutchfield. We recognize the impact that increased orbital traffic has had on space situational awareness and collision accuracy, and saw an opportunity to build a predictive model that highlights high-risk collisions. We focused our findings on Maxar Technology, based on our home state of Colorado.
We identified that our objective was to explore the selected data to ultimately clean and curate datasets for advanced analytics purposes. Using Python, we called both the REST and bulk APIs from the Unified Data Library to extract raw JSON for the data sources here. We then used Python to clean the JSON extracts to transform them into usable data frames. We uploaded all data frames in satellite list into a SQL database. Using SQL to explore the data helped us understand how to use it, a challenge we originally faced. We use Tableau for data visualization and presentation, and Excel and R for advanced analytics and predictive modeling.
To evaluate Maxar's relative performance, we conducted a comparative analysis across all operators in the dataset. Maxar's satellites ranked second highest in launch mass and ranked first in power output, reinforcing their focus on high-performance Earth observation. Greater launch mass and power enable the satellites to carry advanced high-resolution sensors and multiple instruments. Operating exclusively in sun-synchronous low Earth orbit, Maxar satellites are ideally positioned to deliver consistent, high-quality imaging. This combination produces more detailed and reliable data critical for applications such as environmental monitoring and disaster response. Maxar satellites average around 7 years, nearly double the lifespan of most other satellites in the dataset. This extended operational life translates to greater reliability and reduced mission turnover. Across key performance indicators, including durability, power, and lifespan, Maxar consistently ranks above average. These strengths contribute to a relatively lower average collision risk, suggesting a strong foundation for safe and resilient satellite operations.
Now I will walk us through a dashboard we created to help Maxar track some KPIs and look at top conjunction periods. The table on the top shows the same metrics that Julia just walked through, but it does a double click into that other bucket. And so now you can see some of these other operator owner groups separated out, and we can see how they perform across these metrics. Findings are consistent with what Julia shared, in that Maxar ranks among the highest for launch mass, power, and expected lifetime, and has a low collision probability in relation to the other groupings. Below that, we now take a look at peak conjunction periods. So the first table on the left looks at the top 10 months based on number of conjunctions that occurred during that time period. We can see that April of 2023 had the most conjunctions, around 5.6 thousand occurring in that month. And so the visual to the right is now doing an animation for each day of the month, plotting the satellites that existed in that period based on its Cartesian coordinates. Anything in yellow is owned by Maxar, with anything in orange owned by another operator group, and the size of the bubble is representative of the probability of collision. So we can see that Maxar generally has smaller bubbles in comparison. Now I will pass it off to Rachel, who built a predictive model to try to predict the probability of collision for Maxar-owned satellites.
We trained predictive models using non-Maxar satellite data to estimate collision probability, then tested them on Maxar data. Logistic regression showed the strongest performance, slightly ahead of gradient boosting, while beta regression underperformed. Orbit classes and types were key predictors, especially LEO, which had a high risk coefficient and is the only orbit class used by Maxar. Sun-synchronous orbits, the only type associated with Maxar, also showed elevated risk. While we explored features like Raman separation and proximity, orbit regimes emerged as the most influential, suggesting mitigation strategies toward high-risk zones like LEO. Since our model found that LEO and sun-synchronous orbit regimes carry higher collision risk, we recommend prioritizing them for monitoring and mitigation. This targeted approach can help Maxar use space situational awareness resources more efficiently. To improve the model, we suggest adding data from confirmed collisions, time series features like Raman and inclination drift, and environmental and operational factors such as space weather, debris density, and maneuver capability. Maxar already excels at avoiding collisions, but our model can help extend that success. Thank you.